Hello, welcome. Today let's try to solve Leetcode problem 329, longest in a matrix. So let's check what about the descriptions about the problem. So we are given a matrix. So inside it is just numbers. So let's check the numbers. It is always zero and positive numbers. And inside we just need to find the longest increasing path. But I think it is strictly increasing or doesn't matter. Let's check. So from each cell, you can either move in four directions. It means I can go up, down, left, and right. You may not move diagonally or move outside the boundary. So this is also like common sense. Now let's check if it is strictly increasing or not. Longest increasing path. It didn't say that, but it seems it is the strictly increasing because if it is not, one should be connected to 1, 2, 6, and 9 and 9. So it means the strictly increasing longest path. So for this problem, so the easiest way is to using DFS plus memorization. So for the DFS, it is just the template code for each of the position inside the matrix. You just need to use the DFS to find the longest. So for example, if you go through here, you can find the longest. It is a 4. Basically it is the longest than this one. So for 1 goes to here, it is a 3. 1 cannot go to this place and 1 cannot go down. So the longest is 4. So we need to return the final result. It should be 4. Now let's write the final function. Basically I'm gonna prepare a DFS function, and let me prepare a path first. So how should we calculate the result? So we need to calculate the longest. So I'm gonna prepare a result as minus infinite because we need to calculate the longest. Let's check the matrix. So for the matrix, it can be, it will be at least n and m should be at least 1. So it will be at least a 1 times 1 matrix. So basically like this, normally I can get the result according to my DFS function. So I will have a result. But finally, I gotta return the result. But I need to look through all the positions of the matrix to check which one is the longest. Now I need to do some preparations for the DFS function. Normally, I'm gonna prepare R and C. It should be equal to the length of the matrix, and C should be the column. It should be length of the matrix 0. So now I also need to prepare the directions. Because we can go to 4 directions. So it should be 0, 1, and 0, minus 1, and 1, 0, and minus 1, 0. I don't care what is the directions for this one or that one. It is just 4 directions. Because this is also easy to remember. It's just here you just give a 0. At other positions it will be 1 minus 1. It means just up and down. So this means just left and right. Let me check. This one, the 0 though didn't change, but for the column change. It means up and down. So for here, the column didn't change, but the rows change. It means it will be left and right. So this just means 4 directions. Now I need to check for the DFS function, but let me write the main functions first. So for R in range, capital R, for C in range with capital C, so the result should be the max of the result. With the DFS function, it should be R and C. Now we need to put R and C inside our DFS function and calculate the result. Because for each of the grid, if we find one position, it should be at least 1. So this is why the result should be 1, because finally I'm going to return this result for the DFS function. Now I'm going to loop through the directions. So for dc in directions, let me prepare a row and column should be equal to r plus dr. So this means just for directions c plus dc. Now I need to check. I need a if condition to check. So if this row is inside the boundary, it means more than and equal to 0 and less than capital R. Similar for the C, should be more than and equal to, for the column it should be more than and equal to 0 but less than capital C. And we also need to check if it is increasing. So how should we check the increasing? So for the current number, so it is a matrix, row and column. If this number is more than the matrix from the R and C. So this R and C means where are we coming from? So for example, this is R and C, and this is a row and column. So for this one, it should be more than 2 should be more than this one. But we don't need a visited set because basically we are always checking the increasing path. So for this 2, it is more than 1. It means we can never go back. It means 1 can go to 2, but 2 will never go back to 1 because it is not increasing. So this is, I think, it is straightforward. If 2 is more than 1, so 1 can never be more than 2. This means we don't need to prepare a visited set. Because it is straightforward. We can just use this one to avoid the loops for the DFS function. If it is inside, normally we can update the result. So the result should be equal to the max of this result. From the beginning it is 1, and inside it should be DFS row and column plus 1. Why plus 1? Because for here, this one, if it goes out to this number 2, so for DFS row and column for this 2, it is 3. 3 plus 1, it is 4. So the result would be 4. So this is why we need 2 plus 1. Because if we go out, this number always work. And then we need to plus the 4 directions, which one is the longest. If we find the longest, it is more than 1, so we're gonna return this result. If we didn't find, we just need to return this one. So for example, let's first check this number first, this number 9. So we are going to check the DFS. So inside of the DFS, we go to 4 directions. We didn't find any longer path, so it is just 1. So we didn't go through these areas, so we just return a 1. So for this D 0, 0. DFS 0, 0, we're just gonna return a 1. So what about we try to check this one? So for the 6, 6 can go to 9. So 6 cannot go to the right, 6 cannot go down, and cannot go to left. So it means this is a 2. So why it is a 2? Because this result gonna equal to the max of the result. Here is 1. Here DFS for this 9, it is 1 plus 1, it is a 2. Now I think it should be right. Now let me just run it to check if it really works. As you can see, it works. Now let me submit it to check if it can pass for all the testing cases. Basically I think it will get time limit exceeded because I didn't use memory. This is just a DFS. If I didn't use memory, it would be 4 or 3. I think it's 4. 4 to the power of m times n. So m is the length of the rows of the matrix, n is the column of the matrix. It would be a very large number. That is why we cannot pass. But here it seems there are only 4 testing cases missing, but we still cannot pass because the time complexity is too large. Even this m and n is 200, it's going to be a very large number. So we have to use a case. So for the case, we just need to prepare a case for the Python. We just need to put a case, a decorator for this DFS function. Now let me submit it again to check if it really works. Yeah, because after using the cast, the time complexity just becomes O m times n. Yeah, as you can see, it's pretty fast because after using the cast, it's pretty fast. Now let me analyze the time complexity a little bit. So let's check the m and n. So m is the length of the matrix, n is the length of the matrix I, m and n 200. It means it is just for 40,000. It's not a big number. That is why it is so fast, because the time complexity is just O m times n. Yeah, you may think here we used two for loops, and here we are calculating this result. It may be a very large number, but it is not. After using the cast, so everything is inside the cast. Actually, we don't need to do much calculation for the result. Yeah, because for example, for the first pass, if you are using the first pass, for example, this number can go to all of the matrix inside. Normally, for each of the placing inside the matrix has already put it into the cache. So for all other numbers, you just need to check it in the cache for O1. Yeah. So for all others, the result will be just O1 time complexity. So this is why it is m times n. Yeah. Yeah, let me check if it is m times n. So this is m, this is n. Yeah, but here there's just one operation. This is actually O1. I mean, it is not O1, but everything is inside the memory. Basically, the calculation is still this R and C. For the first time calculation, everything is inside the cache. So for the next time when you are using the DFS, actually it is already already inside, I believe. Yeah, so that is why we can pass. Yes, thank you for watching. See you next time.